kids, Flexing Teacher Weber here. I hope you're having a good day. Early in the year, during some of our extra math classes, we started looking at three-dimensional objects. We started looking at building them, and we used blocks to build them, and then we drew them on isometric dot paper, and we also drew the nets of those objects. We did a little bit of that earlier in the year. So just as a little reminder that a three-dimensional object has length, width, and height. So it has depth. Now, earlier in the year, we learned that the net of a three-dimensional object is the flat two-dimensional cutout that creates the 3D shape. So the net are the two-dimensional shapes that create the three-dimensional shape. Now, on the next 2 pages, let's take a look at a net of a cube and a rectangular prism. So this net right here is a cube. It's made up of 6 squares, 1, 2, 3, 4, 5, 6. And when you fold those squares together, you will get a cube. So a cube is made up of 6 squares. And if you remember, there was a day in class where we actually drew the different nets of this cube. And there's actually 11 different ways you could draw this. Main thing you need to recognize is that the cube is made up of 6 squares. Now, the other kind of shape we're going to look at today is a rectangular prism. This is the net of a rectangular prism. The net of a rectangular prism is made up of 6 rectangles, typically like a bottom and a top, a front and a back, and then 2 sides. If you fold this shape together, you can get a rectangular prism, like a box. Now, at school, I have paper copies of these that you can pick up, cut out, and build your own three-dimensional shapes. Or in Shobi, there's an assignment called Build Your Own Three-Dimensional Object, and you can print these off if you have a printer at home and build them. It'd be really beneficial for you to do that so you get an idea of how these things fold back and forth from a three-dimensional object to a two-dimensional object. But we did that earlier in the year in class. Now, what we're going to start looking at today is we're going to start looking at the surface area of a prism or a cube. Now, the surface area of a solid is the number of square units needed to cover the outside. We did this a little bit earlier in the year when we did the painted cube problem. If you remember that problem, it was the problem where we took a cube and dropped it into a can of paint and then wanted to determine how many squares would cover the outside, or how much area that paint would cover on the outside of the cube. So when we're talking about the surface area of a cube, we're talking about the amount of space that covers the outside. So that could mean how much paint goes on the outside, or if it was a gift, how much wrapping paper you need to put on the outside. Now, what we have here is a three-dimensional object. We have a cube. The dimensions of this cube are its length is 6 meters, its width is 6 meters, and its height is 6 meters, because a cube is made up of all sides the same and 6 equal-sided squares. So a cube has length, width, and height that are all the same. Now what we're going to do here is we're going to draw the net of this cube, and then we're going to calculate its surface area. So the net of a cube is really easy, right? That's the thing we looked at back here. The net is going to be 6 squares. So on this next page, we're going to draw the net of this cube. So to do the net, what I typically like to do is I typically like to start with the bottom. So you can see I'm tracing out the bottom right now, and the bottom is a 6 by 6 square. So on my page, I'm going to trace out square and call it BO for the bottom, or body odor. And I'm going to label its dimensions there. It's 6 by 6. Now, just to not take up too much space, I'm not going to put on the units of measurement, which are meters. Okay, so there's our bottom. Now, what I like to do now is unfold the front. You can see this front part that I'm tracing is connected to the bottom. So I'm going to draw a square on the front, which is also 6 by 6, and I will call that FR for the front. And then you can see here, connected down here on the bottom, there's a square on the side and a square on the side, right? Connected to the sides, there's two squares. They don't look like squares because it's a three-dimensional shape the way it's oriented, but they are squares. They're 6 by 6. So connected to that, we'll draw two squares that are 6 by 6. And we'll call that SI for the side. And that's a 6 by 6 square. Again, I'm not putting the units of measurement on just to save a bit of space in my drawing. Now, if you always refer everything back to the bottom, here's the bottom. At the back is another square, right? We could call that the back, the one I'm tracing right there. So, draw another square, same size, 6 by 6. Call it the back, or BA for the back. And then finally, there's also a square right up here. It's actually connected to it's connected at the back here. If you were folding this box open, it could open right there, and there's your final one. We'd call that the top, right? And so the top could be connected to the back. Let's call it TO for the top, and it's also 6 by 6, right? So there's the net of this cube. The net is the two-dimensional shapes that make this cube. Now, we learned earlier in the year, there's actually 11 different ways to draw this. So there's numerous different ways to draw this. The main thing that you have to understand is that this cube right here is formed by 6 squares that have a length and a width of 6 meters in this case. And of course, a square has all sides the same. So that's the net of this three-dimensional object. Now, when we want to calculate, the next thing we want to do is calculate the surface area of this cube. So to calculate the surface area, we want to know the amount of space that covers all of these squares. We want to know the total area of all of these squares. Now, the lucky thing with a cube is that all the squares are the same, so we only need to calculate the surface area of one square and then multiply it by 6 because there are 6 squares that are the same. So let's go to another slide now. We'll do our surface area calculation. Now, there's a math equation for the area of a square or a rectangle. You might have done this math equation before in earlier grades. The math equation to figure out the area of a square or rectangle goes like this. Well, you have to know certain abbreviations. The abbreviation for area is a capital A. The abbreviation for the length of the object is small l. And the abbreviation for the width is small w. Think of these things as the variables. A is the variable for area, small l is the variable for length, and small w is the variable for width. So the math equation to calculate area of a square or rectangle is area equals length times the width. That's how you calculate the area of a square or a rectangle. Take the length and multiply by the width. Now for a square, the length and the width are going to be the same thing. So for this particular one, if we took the area of one of our squares, the length is 6 and the width is 6, right? The length is 6, the width is 6. So to calculate the area of one of our squares, we would do area equals 6 times 6. And area equals 36, and in this case we're talking about meters, and we say squared because that's the number of little squares that would cover the surface of these squares. So when we talk about meters squared, we talk about the number of squares that would cover this space. So the area of one of these squares is 36 meters squared. So we just calculated the area of one of them. But there are 6 squares that are exactly the same size in total. So to figure out the total surface area, so that's the area of one square right there. To get the total surface area, take 36 meters squared, and since there are 6 squares that are exactly the same size, multiply by 6. 6 times 6 is 36. 6 times 3 is 18, plus the 3 is 21. So the total surface area of this cube is 216 meters squared. That means the total amount of space that covers all 6 of these squares is 216 meters squared, or 216 squares that are 1 meter on every side. So that would be a very huge area. And that's the surface area of this thing. That's the area of the outside. We're not talking about what's inside. We're talking about the outside. The total coverage, including the bottom, right? Including under. That's how you calculate the surface area of a cube. Now, in our next video, we're going to look at how to calculate the surface area of a rectangular prism. Hope that helps. That's all for now. Flexing Teacher Weber, out.